In this video, let us understand about elementary transformations of a matrix. There are 6 operations or transformations, 3 of which due to rows and 3 of which due to columns. Let us list them one by one. Let's see the elementary row operations first. Interchanging the rows is the first one. Now, symbolically, how do we represent them? We represent them as Ri moved on to Rj or Rj moved on to Ri. Or interchanging means both get rearranged. Now, multiplying a row with a non-zero scalar. So, we have a row. Again, symbolic representation is, suppose if I consider ith row, then Ri will go to Kri with K not equal to 0. The third transformation would be add or subtract a row to another row multiplied by a scalar. So, what will be the symbolic representation for that? Ri goes to Ri plus Krj. Again, K not equal to 0. So, these are the 3 elementary row operations. Now, these 3 can be extended to the columns also with the liberty of having the concept of transfers. So, we will arrive at 6 elementary operations. Now, let us understand about invertible matrices. If A and B are 2 matrices and if AB is equal to BA is equal to I, then B is called the inverse of A, and we write it as B is equal to A inverse, or since BA is equal to I, we say B is called the A inverse. Now, if I arrive at AB is equal to I, we can say that A is the inverse of A. So, or we can write A is equal to B inverse. Now, how shall we find the inverse of these matrices? Using elementary transformations. Please note that using elementary transformations. So, finding the inverse of a matrix using elementary transformations can be done in 2 methods. So, using elementary transformations, first one by the row transformation method. So, you will apply only the row elementary operations. Second one by the column transformation method. So, it is understood. We proceed only with the column transformations. Now, what is the method involved in it? First of all, if I consider a matrix and if it is inverse exists, then what we shall do if A is a matrix, we shall write it as A is equal to IA. I am sure you are now aware of what is I is, which is the identity matrix. Then what shall we do? We shall perform row operations of A on left hand side and on I on the right hand side. We shall not disturb the A on the right hand side at all. So what will happen? The A which is on the left hand side will turn out to be the identity matrix. A on the left hand side will turn out to be identity, and I on the right hand side will be the inverse of A. So I have explained the procedure for the row transformation method. Yes, we have understood about the row transformation method. What shall we do? The first step is we will write the matrix as A is equal to IA. Now after writing that, we will perform the row operations on A on the left hand side and I which is on the right hand side. So A on the left hand side will turn out to be the identity matrix and I on the right hand side will be the inverse of A. And we will conclude the answer with that. Now how do we proceed with the row transformation method? Same procedure is applied here. We will consider a matrix A and we shall write it as A is equal to IA, and instead of performing the row transformation method, you will perform the column transformation method, and again the same procedure will apply. A will turn out to be the identity matrix ultimately, and then I on the right hand side will be the inverse of A. And hence you can conclude the answer. Note that during the procedure, the A which is on the right hand side should be undisturbed.